Trigonometry, right angle triangle. That's RAT, right angle triangle. There are three things you can do to a right angle triangle, provided one of the angle has got 90 degrees in it, and that's why it's called right angle triangle. I've labeled that angle capital A, this angle here capital B. And because this is capital A, the way we label the triangles in trigonometry is the opposite to angle, that will be little a. Opposite to angle B is little b. So directly opposite. Now opposite to angle C, which is 90 degrees, is little c. And that's how we labeled triangle. And it has to be done like that, because this relationship is what we're working out here, here, and here in the Pythagoras, Socotoire, and the area of a triangle. The Socotoire is also called the trig ratios. So that's the trig ratios. For Pythagoras, it says that the area of B, so if you turn B into a square, and C and A into a square, and C into a square of its own, the area of B, which is, because it's a square, it's going to be B times B, right? So that's B squared, plus the area of A, because it's a square, it will become A times A, because area of a square is A times A. And so therefore you get A squared plus B squared equals to C squared. And therefore to find C, in this case, C will be equal to square root of A squared plus B squared. We can rearrange this by moving B to the other side, and then we get A squared equals C squared minus B squared. And therefore A will be equal to square root C squared minus B squared. Remember, the letters are placeholder for a number. To find B squared is exactly the same thing. So all you need to do is move A squared to the other side. You're going to get B squared here. So we get B squared equals C squared minus A squared. And therefore B will be equal to square root C squared minus A squared. And that's all you need for Pythagoras, because you're only trying to find either the side. That's what you're trying to find with Pythagoras. Either you find in C, or you find in B, or you find in A. But one of the angles has to be 90 degrees. You know how to find the area of a triangle. It's just, because if you turn that into a square, it will be, or rectangle, sorry, it will be B times A. But because we've only got half of it, so it's going to be a half B, AB. Socotoire is basically the first three letters, and the next three letters, and the next three letters are very important. The first three letters is sine. It's written as sine, or you might say sine. Some people say sine. Some people say sin. I'd say sine. So this is sine of an angle. The sine of an angle, in this case, angle A, so sine of angle A, is equal to the opposite of angle A divided by the hypotenuse of angle A. And we can write the hypotenuse here, put The length C is called hypotenuse. So that's the length C. Now the opposite depends which angle you're looking at. If I'm looking at A, the opposite of A is the actual wall opposite A, which is this one here. So that will be A. So sine is defined as opposite, O for opposite, over hypotenuse, H for hypotenuse. And the opposite in this case is A over C. So that's A over C. And therefore, so that's what sine A is. So we can then say, well, if sine A is A over C, so let's just write it here. Sine A equals A over C. Therefore, A will be equal to, well, all I need to do is I want to get rid of sine next to A. So I have to divide on both sides by sine, right? So I get 1 over sine times, of course, A over C. When you do your indices, 1 over A is A to power minus 1. So 1 over sine is sine to power minus 1, A over C. And that is what angle A is. So angle A is sine inverse sine, because 1 over sine is inverse sine or reciprocal of sine, which we call in indices as sine to power minus 1, A over C. And that's how you find the actual angle A. This one is not angle A, this is sine of angle A. And the angle A itself is going to be the inverse sine, which is sine to power minus 1 over A. And you can find that with it on the calculator, because it does have it on the calculator. So if you get a calculator there, switch it on, you can see if you press shift and then you press sine, you can see the inverse sine coming up. That's it. Right. So that's for sine. For cos, cos is complementary of sine. So we say cosine, which is abbreviated, which is now referred to as cos. So we say cosine or cos of A. So that's the second letter. The cosine is adjacent over hypotenuse. So it's A for adjacent. Adjacent is the side next to A. So this is A. A's opposite is little a. And A adjacent is little b. So that would be adjacent over hypotenuse. The adjacent is B over hypotenuse is C. So now we can find actual cos, actual angle A by dividing both sides by cos. So we then get cos to power minus 1 B over C. Again, on a calculator, you can see what that is here. If we put that in, clear the screen, shift cos, there you go, cos to power minus 1. So tangent is just, that's what it means. Tangents will shorten to tan. So tan of A, which is tangent of A, is opposite over adjacent. So it's opposite over adjacent. And that is, the opposite for A is little a. So that will be little a over the adjacent of A is B. And therefore we can find the actual angle, which is tan to power minus 1, open bracket, a over b. So that's how you find the tangent of a. Of course, you can find b as well. So that will be the opposite of b, and this will be the adjacent of b, and that's the hypotenuse here. C, the length C is the hypotenuse. This is opposite or adjacent. It depends which angle you're looking at. If you're looking at B, that's the opposite. If you're looking at A, that's the opposite. So now let's look at the reciprocal ratios. That means the ratio of the three trigs that we've got. We've got sine, cos, and tan. We want their ratios, reciprocal ratios of those. So that means 1 over something. So if I have, so a reciprocal ratio would be, well, I know what sine A is. So 1 over sine A would then be equal to, well, it's going to be the inverse of that. So it's going to be 1 over A over C, which is C over A. So it's actually 1 over sine A is C over A, and that is called, if we do 1 over sine, is actually called cosec. Cosec of angle A. So the reciprocal of sine, so what we're saying is, so 1 over sine is called cosec. That's what 1 over sine is called, cosec. And if you have the angle, maybe let's call it alpha, it will be cosec alpha. And let's do 1 over cos. 1 over cosine. Well, so if cosine is, in this case, cosine of A is B over C, the 1 over cosine of A is going to be C over B. And that is also called sec. Sec of A. So 1 over cosine is equal to sec. So if you have 1 over cosine of beta, it will be sec beta. 1 over tan of A is actually equals to what tan is, A over B, so it's going to be B over A. And that will be, and that's actually called cotan. Cot is cotangent, complementary of tangent. Complementary of tangent. Cotangent. So that's cot, cotangent. And therefore, if we're writing, so if we're writing 1 over tan, and that would be cotan. So if that was tan gamma, that would be cotan gamma. So those are the 3 big relationships we need to think about, and that's called reciprocal ratios. So that means you're doing reciprocal of that, reciprocal of that, reciprocal of that. So that's the first one there. And then you got the 1 over cos, and you got 1 over tan. Pen is running out. Okay.